Critical path analysis. By using critical path analysis, we are going to start looking at work over time and how one piece of work can depend on another. We are going to develop a roadmap for our projects. The essential technique for using this critical path method is to construct a model of the project that includes the following: a list of all activities required to complete the project, typically categorized within a work breakdown structure. The time or duration that each activity will take to complete and the dependencies between the activities. Using these values, the critical path method calculates the longest path of planned activities to the end of the project and the earliest and latest that each activity can start and finish without making the project longer. This process determines which activities are critical or on the longest path and which have a total float, in other words, that can be delayed without making the project any longer. In project management, a critical path is the sequence of a project network activities which add up to the longest overall duration. This determines the shortest time possible to complete any project. Any delay of an activity on the critical path directly impacts the planned project completion date. In other words, there is no float on the critical path. A project can have several parallel near-critical paths. An additional parallel path through the network with the total duration shorter than the critical path is called a subcritical or non-critical path. One of the ways to look over work over time is with a Gantt chart. This one was produced with Microsoft Project. One of the main uses for this type of project management software is that you can enter data just one time and use it many different ways. As you can see, there are 9 tasks listed A through I, with each task having a duration in days. All you need to do is list the starting point for each task, and the chart that is produced shows you graphically all of the work over time for the project. A more powerful tool is to use the critical path method. Critical path method, also called critical path analysis, is a network diagramming tool used to predict total duration. A critical path for a project is a series of activities that determine the earliest time which a project can be completed. It is also the longest path throughout the network diagram and has the least amount of slack or float. Slack or float is the amount of time that an activity may be delayed without delaying a succeeding activity or the project finish date. Let's look at how it works. Here is a critical path for a particular project. The circles are called nodes and are simply starting and end points and activity junctions. Here is the associated Gantt chart. You will notice that from the starting point of the project, node 1, there are 2 activities whose duration are 10 and 5 days respectively. As you can see, each one of the activities are listed in the critical path method with the added information of the dependencies. You will see that activity H depends on activity F's completion. Activity F depends on activity D's completion, and activity D depends on activity A's completion. All of the paths work this way. Let's look at some of the actual paths of the workflow. Path 1 goes from node 1, the start of the project, through node 2, 4, and 5, and then to node 7, the end of the project. The work activities are A, D, F, H, with the path having a length of 27 days. Now let's look at the longest path. It is path 3. It follows nodes 1, 2, 3, 4, 5, and then 7. The work activities are A, C, E, F, H. The duration of this path is 37 days. The critical path shows the shortest time in which a project can be completed, which is the longest path. If one or more of the activities on the critical path takes longer than planned, the whole project schedule will slip unless the project manager takes corrective action. It is important to know what the critical path is throughout the life of a project so that the project manager can make trade-offs. If one of the tasks on the critical path is behind schedule, should the schedule be renegotiated with stakeholders, or should more resources be allocated to other items on the critical path to make up for that time? It is also common for project stakeholders to want to shorten project schedule estimates, so you need to know what tasks are on the critical path. Let's look at the steps in creating your critical path. From the work breakdown structure, a listing can be made of all the activities in the project. This listing can be used as a basis for adding sequence and duration information in later steps. Some activities are dependent on the completion of others. A listing of immediate dependencies of each activity is useful in constructing the critical path or CPM network diagram. Once the activities and their sequencing have been defined, the CPM diagram can be drawn. The time required to complete each activity can be estimated using past experience or the estimates of knowledgeable persons. CPM is a deterministic model that does not take into account variation in the completion time, so only one number is used for an activity's time estimate. The critical path is the longest duration path through the network. The significance of the critical path is that the activities that lie on it cannot be delayed without delaying the project. Because of its impact on the entire project, critical path analysis is an important aspect of project planning. As the project progresses, the actual task completion times will be known and the network diagram can be updated to include this information. A new network critical path may emerge and structural changes may be made in the network project requirements change. If project requirements change, I apologize. The critical path method lists all the activities of the project in a graphical format. It shows the duration of each activity and the dependencies of each activity. CPM models the activities and events of a project as a network. Activities are depicted as nodes on the network, and events that signify the beginning or ending of activities that are depicted as lines between the nodes.